Serverless architecture represents a significant shift in how applications are built and deployed. In this model, cloud providers automatically manage all the underlying server infrastructure, scaling resources up or down as needed. This means developers no longer have to worry about provisioning, maintaining, or securing physical servers or containers. Instead, they can dedicate their efforts to writing and deploying code, while the cloud platform handles the rest. This approach streamlines development, reduces operational overhead, and allows teams to bring new features to market more quickly. As a result, serverless architecture is becoming an increasingly popular choice for modern application development. Serverless architecture is defined by several distinctive features. One of the most notable is the elimination of server management, meaning developers do not need to provision, maintain, or scale servers themselves. Instead, applications run in response to specific events, such as HTTP requests or database updates, following an event-driven execution model. This approach allows for automatic scaling, where resources are allocated dynamically based on demand, ensuring efficient performance even during traffic spikes. Additionally, serverless platforms employ micro-billing, charging only for the exact amount of computing resources consumed during execution. These characteristics make serverless architecture highly flexible and cost-effective for modern application development. Serverless computing has transformed the way developers build and deploy applications by abstracting away infrastructure management. Among the most popular serverless services are Function as a Service, or FaaS, and Backend as a Service, known as BaaS. FaaS platforms, such as AWS Lambda, Google Cloud Functions, and Azure Functions, allow developers to run code in response to events without provisioning servers. On the other hand, BaaS solutions like Firebase, AWS Amplify, and Azure Mobile apps provide ready-made backend features, including databases, authentication, and storage. These services enable rapid development and scalability, making them attractive choices for modern cloud-native applications. Major cloud providers continue to expand their serverless offerings, catering to a wide range of use cases and developer needs. Serverless architecture is widely adopted across various domains due to its flexibility and scalability. Web applications often leverage serverless platforms to handle dynamic user requests without the need for managing underlying infrastructure. Real-time file processing is another common use case, where serverless functions can automatically respond to events such as file uploads or modifications. Scheduled tasks, like sending notifications or generating reports, benefit from serverless automation, running precisely when needed. In the realm of IoT, serverless solutions efficiently process and analyze data from connected devices. Additionally, chatbots utilize serverless backends to manage conversations and integrate with other services, ensuring responsive and cost-effective interactions. Serverless architecture offers several compelling advantages for modern application development. By eliminating the need to manage servers, organizations experience significantly reduced operational overhead, allowing teams to focus more on coding and innovation. Cost efficiency is another key benefit, as resources are allocated dynamically and you only pay for actual usage, minimizing wasted expenditure. Built-in scalability ensures that applications can handle varying workloads seamlessly, automatically adjusting to demand without manual intervention. Additionally, serverless platforms enable faster deployment cycles, making it easier to release new features and updates quickly. These advantages collectively empower businesses to be more agile and responsive in a rapidly changing digital landscape. While serverless architecture offers many advantages, it also presents several notable challenges. One common issue is the cold start problem, where functions may experience delays when they are invoked after a period of inactivity. Execution time limits can restrict the complexity of tasks that serverless functions can handle, making them unsuitable for long-running processes. Vendor lock-in is another concern, as applications built for one cloud provider may be difficult to migrate to another due to proprietary services and APIs. Debugging serverless applications can be more complex compared to traditional architectures, given the distributed and ephemeral nature of functions. Additionally, the stateless design of serverless functions requires developers to find alternative ways to manage persistent data and maintain context between executions. Let's walk through a practical serverless flow for handling an API request. When a client sends an HTTP request, it first reaches the API gateway, which acts as the entry point and manages the routing of incoming traffic. The API gateway then forwards the request to a Lambda function, which contains the core business logic for processing the data. Within the Lambda function, the request is validated and any necessary computations are performed. If the workflow requires storing or retrieving information, the Lambda function interacts directly with DynamoDB, a scalable NoSQL database service. After completing its operations, the Lambda function returns a response, which is sent back through the API gateway to the client. This streamlined process eliminates the need for managing servers, allowing for efficient and scalable API handling. In summary, serverless architecture represents a significant evolution in application development. By abstracting away the complexities of infrastructure management, developers can concentrate on crafting and refining business logic. This shift not only streamlines workflows, but also accelerates the deployment of new features and services. As a result, organizations benefit from enhanced efficiency, reduced operational overhead, and the ability to scale applications seamlessly. Ultimately, serverless empowers teams to innovate faster and respond more effectively to changing business needs.